So today, we're going to start with finishing up the information from the 18.1. So just as so we were talking about like the landfills and stuff like that yesterday, right? Today we're going to finish these up, talking about combustion. So combustion facilities. Now, when we're talking about combustion facilities, we're not talking about somebody burning trash in their backyard. Okay, what we're talking about is actual facilities designed to burn trash. In your books, they do have an example, like a little picture here, and basically what you can see is like they've got the trash coming in, and then they're like this part here is like kind of like separating it out into stuff that can be recycled, and like you get usually turned like they can turn some of that into money, like metals and stuff like that are pulled out, and they uh, then it gets like shredded and sent to the combustion chamber. Now this one, if I can get it to actually focus in that. Yeah. Well, so this one does. They when they burn it, um, when they burn the different materials, this one has a thing where you've got a um, like basically some kind of water, some kind of fluid uh, that when it burns, it heats that up and it turns into steam, and then they use that to run a turbine generator and generate electricity from the combustion. So now, not all combustion facilities would necessarily have this ability, but really, and to make it efficient and um, to help the cost of it, like you really need to have that as part of it to make it really work. So, they use that heat to generate energy. Then, like they've got another. So after they burn stuff, they've got different sort of like aspects where it will well, certain things will drop to different areas. Like there's a part that goes to a metal recovery system for any like things like metals that went through that kind of slipped through the first part. Uh, and then they've got this lime reagent helps neutralize uh, certain types of gases and stuff like that. And it's basically like all of these steps, just to sort of make it simplified, all of these steps are to uh, decontaminate and clean up anything that comes out of the combustion chamber, whether it's gases and air or whether it's solids, stuff like that. So the fly ash is basically like the product that's left over afterwards. Um, and then you can see there, this would be the stack um, for any of the gases that from the combustion that are left over after it's gone through all the decontamination and filtering processes. Okay. Um, so that's what we're talking about when we talk about a combustion facility. So what are some advantages of combustion facilities? As it says, it can reduce the weight of trash by more than 90%. And when we talk about weight, we're talking about the amount you're putting in, right, as well. So that's a big advantage. Um, Toxic or hazardous substances are concentrated into two ash streams, which are easier to control and handle safely. Number three is actually a big one as well. Um, no changes are needed to the public's current behavior or trash collection procedures. Um, that's a big deal. It's hard to get people to change, just in general, And if you can, do something that essentially doesn't require people to do anything differently, then they're much more likely to use that or accept it if it works, right? Um, 2/3 of combustion facilities at the time this was written, so hopefully it's even more now. 2/3 of combustion facilities have modern emission control technology to reduce air pollution. Be some of the stuff that we saw there. Combusted MSW releases 35% as much energy as coal, which can be converted to electricity. So you might look at that and you're like, okay, so you would only get 35% of what you would get if you burn the same amount of coal. But remember, we're burning trash. That there's really nothing else we're going to do with it. So getting any percentage of energy from it should be beneficial, as long as it doesn't, as long as the process doesn't require more energy to use to get to that point, then you can create. Um, Many combustion facilities also have recycling facilities to remove any materials that can be recycled before the MSW is burned. So we already saw that. So what are some drawbacks of combustion facilities? Well, as you can imagine, air pollution and offensive odors. And again, 2/3 of them have modern emission control to reduce air pollution, but you're still going to get some air pollution with it. And even with cleaning it up, kind of like the sanitary landfills, there's still going to be some drawbacks. You can smell smell stuff, things like that, right? Um, they're expensive to build initially because you've got all the different components. So they're expensive to build initially, and siting issues, like with anything else with trash, you're always going to have siting issues. Now this one, your book lists, I don't know if I really see this as a negative. I'll explain why in a second. Ash from the combustion is often loaded with metals and other hazardous substances that have to be disposed of in a safe, specific manner. They have it listed in the book as a drawback. I don't know if I agree, and here's why. That stuff was in the trash already, right? Mm-hmm. Is burning it making it more hazardous than if it was dumped in the ground? I don't think so. The only way that it would make it more hazardous is if it went through some kind of chemical reaction, which burning is a chemical reaction. If it did something that made it more hazardous, even if they would say, well, it's more concentrated, okay, more concentrated, that's fine, but you would still have to deal with that safely. So they have it listed as a drawback. I don't know if I see it as a drawback. I think you have to deal with that stuff anyway, because it's hazardous no matter what you do. If you bury it or burn it or whatever, like, it's just a matter of dealing with it. So the fourth one seems weird, but it is a concern. To justify the cost of operating these combustion facilities must have a continuous stream of MSW. In other words, they have to have enough trash to make running it worth it. Okay, and you might say, like, well, we're producing like literally tons of trash. That shouldn't be a problem. Well, it's not a problem, but you also have to realize, like, if you might need to pull from a wider area, and then you have to find people willing to ship it there or whatever, stuff like that becomes conceptually an issue. So, not that it can't be done, but it can be, it's something they have to work out, right? Even if the facility generates electricity, the process wastes both energy and materials unless it's combined with recycling and recovery. So this is kind of what I was talking about before. You have to have, in order to make this like energy neutral or better, you have to have recycling and recovery as part of it. Otherwise, it uses more energy than it generates or whatever. And the process uses more energy than it generates. Okay? So, all right, questions on any of that? So, I mean, what do you guys think about combustion then as an option? Like, yeah.
I mean, I think it's probably the smartest way of, like, just getting the trash gone. Like, and like, I know it just getting it gone. You know what I mean?
Mm-hmm. Yep.
Like, especially if they're scrubbing all the stuff, all the harmful stuff out of it, I see no problem with just burning it.
Yeah.
I mean,
no, that's good. Anybody else?
I mean, they get, like, when they burn it off, they get, like vents that can, like, clean the stuff,
like filter out and whatever. Yeah. So the one thing that they didn't mention in here, that to me would be one of the drawbacks to using combustion facilities more, would be there's a difference between like pulling air pollutants and stuff out and just what gases are being released as a byproduct of the combustion reaction. So like combustion reaction in general, like for those of you that had chemistry, you probably hopefully remember seeing this at some point. You have a hydrocarbon and oxygen, and the products are carbon dioxide and water, and that would be of like complete combustion. This is what your products would be. So, so combustion. Uh, now that's not all combustion is of a hydrocarbon, obviously, but like you get the idea. So my only thing with that would be is if we really ramped up the combustion, um, my guess is that even cleaned and scrubbed, we'd be putting a lot more carbon dioxide in the air, which isn't fantastic for climate change and stuff like that. So that would be one drawback. Um, Now, if they could find a way to, in an ideal world, that's a lot of carbon dioxide. It's a shame that they couldn't then vent that into some place that would then like grow plants or something, or like something that could use that and lock that carbon away instead of releasing it into the air. But I think that would be one reason, probably. Yeah.
Actually, I was about, I think it was in my psychology class, or watching CNN 10, and what companies will do if they have like high carbon emissions, they'll buy like, one of the ways is they'll buy into like these seaweed patches, because seaweed grows so fast, it'll suck they'll buy the amount it takes to become like the amount of seaweed.
To like offset.
To offset it.
Yeah.
To become neutral.
So when you say that's really interesting. When you say buy the seaweed, like
there's.
I think when you
No, they
describe it as like they're like buying like a bunch of seaweed and they're growing seaweed.
Yeah, but it's not like the company. They're going through like this like company that grows it. It's super.
So, but they are like paying to actually have it be grown or whatever.
Yeah.
Okay.
That's
interesting because like I was thinking like is it like one of those things where you like you adopt you adopt an elephant or whatever when you're not really doing that, you're just paying money to help whatever.
Yeah.
But but in that case they're actually paying to actually have some grown.
They're actually paying for it, I think, just
Cool.
straight up.
Yeah, that's interesting.
And then they'll cut it, and then they'll sink to the bottom, and then the carbon dioxide naturally will get stuck out.
Yeah, that's really cool. Yeah, that's so plants are natural what are called carbon sinks, which means they absorb and then lock carbon into their structures, and then obviously like you're saying when they die, then it and they decompose, then it gets like basically locked in structures and things in the earth, which is where in the ground, which is where we want it versus in the air as much. So that's really fascinating. That's interesting. I'd have to. Do you remember where you were looking that up?
It was on CNN 10. I think it was like either yesterday's or the day before that. I think it was. I know it was.
Then it's basically companies purchasing
seaweed, but I bet you can just look it up as like a headline. Pop up.
Seaweed to offset carbon emissions. I'll have to look that up. Okay. All right, so I'm going to stop this.